Okay, so let's go ahead and take a look then at figuring this out. Well, as we can see that this larger rectangle, that this half, let's call it a globule figure here. All right, this larger rectangle here is 2 across and 4 tall. So that's going to cover a 2 by 4 area, which they're showing you right here is 8. And this smaller rectangle here, all right, well, that's covering an area that's 1 across and about 2.5 tall. So that's 1 times 2.5, which is what they're showing you here, 2.5. And so then we can combine those to find the area of the combined globule there. And 8 plus 2.5 is 10.5. So it roughly covers 10.5 grid boxes, which is really a pretty good estimation there of the area of the composite figure. All right, now here are some more composite figures, not drawn on grid boxes this time though, and we're supposed to find the perimeter and the area of the composite figure. Okay, so you've got some options here when you work with these things, but with the perimeter here, it's really easiest to just continue talking about just adding up the sides here. So even though that's a lot of adding here, we can handle it. We've got, as we go around the shape, and I'll make this a little bit larger so it's easier for you to see. As we go around the shape, that means we're going to be adding up 6 and 3, and 6 and 3, and 6 and 5 and 5, and then look at this bottom piece. Well, the bottom piece isn't labeled, but we know from translating what's above down that this area must be 6, and this area must be 6, and this area must also be 6, so 18. So to all those numbers we just put together, we're going to add 18, which accounts for this bottom piece, again, being the same as the pieces directly above it being put together. And yes, I know that's a lot of addition, but ultimately that's the way we're going to come up with our perimeter here, our distance around our shape, and that's 52 units. And that's our perimeter. Now, as far as the area here, you've got some options. What they've done for the area here is they've actually divided this into 3 pieces. They took and they cut the shape up. If I bring my magnifier back here, we'll take a look at this. We can chop this up by putting some lines here, and this will form 3 rectangles. And what they're going to do is they're going to find the area of each of those rectangles and combine them, and then when we combine them, that would then be the area of the composite figure. Of course, there's other ways you could chop this up. You could put a line here like this and one here like this, and then you'd have this kind of long, skinny rectangle, and then these two. That would also work. The area is going to be the same either way. Okay, so let's talk about the way they're approaching this question. So we've got this rectangle piece on the left here, which is 6 by 5. And this rectangle piece on the right here is 6 by 5 as well. Now the one that's probably a little bit of work here is this middle piece, because as we drop these lines down here, there would actually have been no numbers given to us there. But we know that the whole distance is 5, and the distance from here to here is 3. Well, how do I know that? Well, from here to here it's 3, and that would of course just translate directly over, which means that this little segment here has to be 2, because my 3 plus my 2 is going to make my whole distance of 5. And that's why here they're saying it's a 6 by 2 rectangle, 12. And then we're going to go ahead and simplify our calculations here. Notice the way they've written this here is with the order of operations, so 30 plus 12 plus 30, which is 72, and that's 72 units squared. Now, not to dwell on this question too long, but you do have another option here for finding the area that might save you some time. What you can actually do is make a more complete shape. And by making a more complete shape, what I mean is we're going to add a line right there. And as you can see, that's just going to make one giant rectangle. And going across, it would be 6 and 6 and 6. Again, this little piece would translate up, just like the bottom, so that's 18. And it's 5 tall, so we've got 18 times 5 there for the area, which is 90. Some of you are wondering, well, how does that help me? You didn't really find the area of what's there. Well, actually I did. what I'm going to do now is I'm going to subtract off this little piece that I added on. Well, that little piece that I added on there was 3 by 6, which is 18. And so now to find the area, I'm just going to do 90 minus 18, which is 72. You have the option of doing whichever method works best for you. Do whatever is appropriate for the question. There are times where it's going to be easier to divide it up and work it in pieces. There's going to be times where it's easier to make a more complete shape and then take the little bit you add on off to come up with the solution. In this particular question, taking that and adding a little bit and then subtracting off a little bit I added on there seemed like it was a little bit less work to me and might have seemed like a little bit less work to you. Again, it really just depends on the question. So let's conclude here with check it out examples. We've got the one in question number 1 there that's asking me to find the perimeter of the figure. So again, that means we're adding up all the sides in the figure. We've got a 6 and 11 labeled there, but remember, you've got the sides that aren't labeled that you have to account for as well. Since this is a rectangle, this has to be 6 as well, and this has to be 11. So that's 11 plus 6 plus 11 plus 6, and that's 34. And so 34 units is going to be the perimeter of the figure. Let's say I asked you to find the area. What would you do? Well, remember, area of a rectangle, base times height, length times width. So the area would be 11 times 6, or 66 units squared.